Hey everyone, Santat here. Hope you all are doing great. And welcome to the Research Commission, the series where we go really in depth into the science and technology that we can learn from video games. So if you're new here, which I think most of you are at this point, a lot of my videos I've done lately are, I would say, something like 20% science and technology, 80% video games. Every now and then, I like to go all the way in the other direction and do sort of like an 80% science and technology, 20% video games, so we can just learn some, genuine, real skills that you can apply to not only video games, but also your everyday life. So this video has been inspired by two things that's been occurring lately. So one, a lot of people in my comments have been asking me again and again why I choose to use Attack Boost 5 and Crit Boost 3 in Monster Hunter Wilds over Crit Boost 5. That's something that I think is very straightforward to answer via rather straightforward programming skills. The second thing is I've been lately posting in my community tab a lot of skill comparisons between how good, for example, Master's Touch is versus Razor Sharp and Handicraft. And I've been getting a few questions, most notably via Fox Invictus, who's a Switch Axe speedrunner and set builder, how I actually make graphs and plots like this. So that's what we're going to be doing today. Today, we're going to learn the fundamentals and basics of Python programming and how we can use that to do Monster Hunter math like a physicist, around the question of attack boost or critical boost. Now what's cool and exciting is lately, Google has been doing some really cool stuff with this thing that they have released called Colab. And what Colab is it's a free product, just like Google Sheets or Google Docs, where anyone, anywhere, can use Google servers to do some very simple code here via Python. So, if you have a Google account, which you probably do if you're watching this video, all you need to do is you can click the link in the description below, and you can see this, what we call notebook is. You can see this notebook, which is what I'm writing in, which is what I'm coding in, and you can follow the code yourself, and you can run it as we do it on screen here. Okay, so make sure you click that link and check out this Python notebook on Google Colab. Cool? Cool. But before we even start coding, if we're going to try and be good scientists, good physicists, you've got to make sure that we start well from the fundamentals. And the most fundamental and important thing you can do as a scientist is to make sure that you have a good, valid question. We want to make sure that a question is two things. We want to make sure that it's testable, and we want to make sure that it's interesting. Okay? So what do I mean by that? By interesting, I just mean that it's something, conventionally, that you or I think is interesting. It's pretty important, because if I don't think a question is very interesting, I might give up halfway through. If you don't think it's interesting, you aren't going to watch this, I'm not going to get paid, either by you or, like, in my actual science job. So a question needs to be interesting. And two, a question needs to be testable. It needs to be something that we can actually find the answer to via methods that we have access to. Okay? If we can't actually find the answer, the question scientifically isn't going to be a very good one. So here's some examples. So an example of an interesting but not really testable question is, for example, how good is the steel flare? Because in this case, what does good even mean? There are better questions that you could ask. You could ask, for example, how many fewer hits does the flare make you need to create a wound against a certain monster in Monster Hunter Wilds? That's a bit more of a testable question, but how good is flare isn't really testable. An example of testable but not interesting question could be, how much defense do we need to not be knocked out by 7 mega barrel bombs? Very testable, not a very interesting question. Okay? So the question that we are going to ask, and we want to be as precise as possible, is, under what conditions will Attack Boost 5 and Crit Boost 3 do more damage than Crit Boost 5 and Attack Boost 3? Okay? It's very testable because you can figure out exactly what all those skills do. And I think it's interesting, and if you're looking at this channel, you probably think it's interesting because doing more damage is always interesting in Monster Hunter Wilds. Okay? So, we have our testable and interesting question. What we want to do next is we want to split our big, complicated question into some nicer, easier to handle questions. So for example, what does attack boost do? What does crit boost do? And what's the damage difference between attack boost and crit boost? So each of these questions are a bit simpler, and these are questions that we can actually try and answer. And the third step, and the biggest step, is we need to convert our human questions like these into computer questions, into questions the computer can answer, in this case, via Python. And this is where we start. So today we're going to go through the very basics of Python, including three main things. 1, functions. 2, if, else, and conditional statements. And 3, math and comparisons. And luckily this question gets us through all of these three things. Okay? So, functions. So the building block of Python and any other programming language is a function. A function does something, okay? So in Python, when you want to create a function, we write down def, so we define a function. We give it a name. So we're going to say the name of function is going to be, I don't know, my function. And a function requires, may require an input. So we're going to call our input input, doesn't always. And a function may also spit out an output. And over here, it does something else. So let's just say that our output is going to be input plus 5. Okay? So we create a function called myfunc, which takes an input and spits out an output, which is the input plus 5. So the input is 2. The output should be 2 plus 5, which is 7. Okay, so that is straightforward, but a very fundamental building block to what we're going to do for attack boost, okay? Because what attack boost does is it increases the value of our attack by some value. So let's create a new function. We'll say our function is going to be called apply attack boost. And we're going to put in our raw attack value. And we're going to also put in our attack boost level, okay? So right now let's pretend our attack boost level is going to be 1, okay? We're going to return our total raw. And so what attack boost 1 does is it increases our raw by 3. So we're going to say our total raw is going to be our raw plus 3. Cool. So let's try that out. Let's say we're going to apply attack boost to our raw. Let's say we start off with 100. Our attack boost level is going to be 1. So our total raw is going to be 103. Nice. Very simple math. But our attack boost could be multiple different levels, right? It could be 1, 2, 3, 4, or 5. So this is where we're going to do some if and else statements. So what if does is it basically says if something happens, we'll do a thing. So if our attack boost level is 1, so equals just means, so double equal sign is what a normal equal sign would be in math. So it's basically saying, oh, are these two things the same? Is attack boost level 1? If so, we're going to say the total raw is raw plus 3. Okay? So let's try that again. Attack boost, apply attack boost level 1 to 100. We get 103 attack. Nice and good. Now, what happens if we do attack boost 2? So we want to type in elif. So elif means if that's not the case, the new thing that's going to have to happen, the new thing we're going to check for is if we have attack boost level equals 2. Attack boost 2 increases our raw by 5. So we're going to say raw plus 5. So when we apply attack boost 1, we get 103. Apply attack boost 2, we get 105. Cool. Let's do that a few more times. So attack boost 3, that gives us 7. Attack boost 4 is when it gets interesting. Because in Monster Hunter Wilds, what happens is we multiply our attack by 1.02, and then we add 8 at the end of it. And attack boost 5, we multiply it by 1.04, and then we add 9 at the end of it. So let's do that. Attack boost 2, we have 105, that's good. Let's check attack boost 3. Oops. Attack boost 3, we should get 107. And attack boost 5, we should get 114. Sweet and good. Now I've had a bit of a problem. If we apply attack boost 6, what happens is we get a big error because attack boost wasn't 1, 2, 3, 4, or 5. So something weird happened. What I want to say is maybe if we get attack boost above 5, it's just going to act like 5. So we'll say if it's greater or equal to 5, it's going to act like 5 and give us times 1.0. That was a typo. Times 1.04 plus 9. So it should give us 113, which is correct. Okay. Still a bit of an error, because if we go to anything else, if we say attack boost is 0, we get an error. So let's just say else our total raw is just going to be our raw. Okay. So our attack boost is 0, we'll get our original attack boost. Okay. So I did miss something else out here, and I think that's what a lot of the comments were asking about. Because attack boost doesn't just multiply our raw by 1.02 or 1.04. It multiplies something we call our base raw, or the raw we get from our weapon. See, if we get bonus raw from other methods, so things like eating food, or certain skills like agitator or burst, or stuff like a demon drug, this isn't actually affected by our by the 1.02 or 1.04 multiplier. Okay, so what you want to do actually is you want to say our total raw is going to be our total raw plus our bonus raw at the end. Okay, the bonus raw isn't going to be affected by the 1.02 multiplier. And the one last thing we want to try and do, if we're very good programmers, is we want to make sure from the start that we comment our code. Okay, so if we type in this hashtag or the sharp, we can type in anything we want, and it's not going to affect the code. Okay, so this is just something that humans can read and the computer will ignore. Okay, and this is very important because this is a nice message to other people who read the code, and honestly, and most importantly, your future self, about what you just did. Okay, so we're going to write down this note for you and for myself in the future. This function applies the attack boost skill. Okay, and it's nice to know what we need to put in. So we're going to say raw is the raw attack value of a weapon. We're going to say bonus raw additional attack you get from armor skills, etc. And we're going to say attack boost level is the level of attack boost. That one's a bit obvious, but nice to know for the future, okay? Your future self will thank you if you comment your code, and your future self will be very upset with you if you do not. So it's very important. Okay, so we've answered the first question we wanted to ask. We've answered how much damage does attack boost do. Let's answer the next question. How much damage does crit boost do? And this one's actually a bit easier question. Because crit boost is a lot more simple to code. So, we're going to make a new function, which we're going to call apply critical boost. And all a critical boost does is it spits out a critical modifier, which is based only on your critical boost level. Okay, so what critical boost does is it increases our critical modifier. So normally our critical modifier is going to be 1.25. Okay, and this increases the 1.25 by 0.03 for every critical boost level. Okay, which actually means that it's just the critical boost level times 0.03. Does that make sense? So the critical modifier is actually just going to be the critical boost level plus the critical boost level times 0.03. You can put that in brackets, but the brackets aren't necessary here. Order of operations means that the times goes in first. And that's how we get a critical modifier. That is how we apply a critical boost. So let's test that out. If we have a critical boost of level 0, our critical modifier will be 1.25. Nice. At critical boost 1, it's 1.28. Nice. And at critical boost 5, it's 1.4. Nice and good. At level 6, it's going to tell us it's going to be 1.43, which we don't want at all. So let's tell it that. So we're going to say that the critical modifier is going to be the minimum of what it used to be. and 1.4. So this means it'll never go above 1.4. Yep, and if you do another value, a normal value, it'll be correct. And let's also say that it's going to have a maximum of 1.25. So if somehow we messed up and wrote down a critical boost of -1, it's going to still be 1.25. Okay, so that is critical boost. And now that means it's time to comment. Sweet. Now, how do we turn our critical boost, our critical modifier, to an actual damage value? We look at how critical and affinity works in Monster Hunter. So how critical this work is okay. So if our critical hit rate is 0, even if our critical modifier is 1.25, our effective critical modifier, like how much it actually increases our damage, will be 1. It's not going to do anything, right? And if we have 100% affinity, our effective critical modifier will be our real critical modifier, right? So what I mean by that is I want to create something we call an effective critical modifier, which is just our critical modifier, reduced by our affinity value. Okay, so let's do that. Let's say def. Okay, so our function will be called, I don't know, calculate effective critical modifier, and that's going to depend on our critical modifier and our affinity value, or our critical rate. And let's go. So what we can do is we can either land a critical hit or we don't, right? So the chances of landing a critical hit, so the proportion of crits is going to be our affinity divided by 100. So if our affinity is 70, then 0.7, 70% of our hits will be criticals, and the proportion not crits is 1 minus that. So if it's not a crit, it's not a crit. Prop of crits. Okay? Now, when we land a critical hit, what's going to happen is you'll multiply our attack by the critical modifier we have. And when we don't, okay, so the damage from crits is going to be the portion of crits times critical modifier, and the damage from not crits is going to be the portion of not crits multiplied by 1, since we'll just be doing normal damage, right? And so the effective critical modifier will just be the damage from crits plus the damage from not crits, and then we will return our effective critical modifier. So let's test that out now. So calculate effective critical modifier. If our critical modifier by default is 1.25 and we have 100% crit rate, our critical modifier is 1.25. Nice. And if we don't land a crit, our modifier is 0. That's good. That's a good sign. If it's 1.4, it'll still be 0. Yep. 100, we get a 1.4 bonus. If half of them are crits, 50% the bonus. That's nice. So we have calculated our effective critical modifier, which means we can combine this function, calculate effective critical modifier, with apply crit boost to figure out how much damage crit boost does. Let's comment this again. So, sweet. So I think we are actually approaching the end of this coding challenge. So what we need to do now is we can say that our damage, def calculate damage, is going to depend on our what do we call it? Raw and bonus raw. Bonus raw. It's going to depend on our affinity. It's going to depend on our not our critical modifier, but our critical boost level and our attack boost level. And our critical boost level. So what's the formula? First, we got to calculate our total raw. So our total raw is going to be what we get from attack boost onto our raw, our bonus raw, and our attack boost level. And then we're going to create a total raw after critical. Okay, now we'll create our effective, we'll calculate our effective critical modifier, which is going to be our critical modifier and our affinity, and our critical modifier is going to be what we get from apply critical boost on our critical boost level. I have a typo up there, I can fix that. Critical boost, not critical boots. Critical boost level. So that function goes in there. So our effective critical modifier is going to be our apply critical modifier on this guy. Sweet. And now our damage is just going to be our total raw times our effective critical modifier, and then we return our damage. So let's calculate damage, starting with our raw of 100. Let's get a bonus raw of 10, an affinity of 50, attack boost level of, let's start with 0 and 0 for now. We have some errors, which is normal, which is perfectly fine. Apply effective critical modifier is not, oops, defined because it's actually called calculate effective critical modifier. Let's fix that up. Sweet. And return damage, yes, so our damage is 123.75 from this initial condition. Is that right? I think it is. Let's start with something we know off the bat. So if our raw is 100, our bonus raw is 0, and our affinity is going to be 0, our damage should be 100. Yeah, should be what we started with. Yep. And if we add something here, say 2, then yep, that works out. Our affinity is 100, we should have the 1.25 modifier. Yep. And if our critical boost level is 5, that should be 140. Sweet. And if our increase our attack by 3, sweet. That 1.4 times 3, that checks out. Sweet. So we have a function that can calculate our damage from our stats and our levels of all of our skills. Cool and good. And now what we can do is we can check our different attack boost levels and our crit boost levels, right? Let's make another function for that. Let's make a function called def define. It's going to be find difference, and we're going to put in the same things we have: raw, bonus raw, affinity, attack boost, and crit level. But instead of just having one, put an enter here just so you can see better. Instead of just having attack boost one different attack boost level, we can call this one attack boost A and critical boost A. And we can make a attack boost B and critical boost B, and that way we can compare it a bit more easily. And then what we're going to do is going to return a difference, and our difference is going to be okay. We're going to say damage 1 is going to be calculate damage on all of these things, and we're going to say our damage 2 is going to be all these things on attack boost A and critical boost A. Attack boost A and critical boost A. And our damage, let's call that A and B actually, just so we are consistent. Critical boost B. And then our difference is going to be damage A, difference is damage A minus damage B. We have an error, as usual. What's the error? The error is invalid syntax. I've got a comma over here. Okay. So now we should be able to find a difference. Say we start 100 raw with a bonus raw of 0. Affinity is normally going to be 0. Now, say attack boost A is going to be 5, and crit boost 3 is going to be crit boost A is going to be 3, and attack boost 3 and 5. So this is comparing attack boost 5 and crit boost 3 versus attack boost 3 and crit boost 5. And what it's saying is version A with attack boost 5 and crit boost 3 is going to be 6 higher than the opposite. So under these conditions at least, okay? Which is basically saying attack boost is better than crit boost in this specific situation. However, we can change the situations. Let's make this a bit more clear. So we're going to say, make sure our raw is a 0, our bonus raw is going to be this. So in Python we can specify exactly what we're going to give to the equation, and I'm doing that now just to make it a bit easier, just to be clear of what we're trying to say. So boost is going to be that, and attack boost B is going to be that, and the last thing is going to be critical boost B is going to be that. So under these conditions, the difference is going to be 6. Actually, I don't think I like difference. Personally, I usually like doing difference as a percentage, because I think that's more meaningful. As percent. I think it's usually a bit easier to understand. So we're just going to divide this by what we initially had. By our damage A. So this is basically saying how much, as a percentage, is damage A better. So damage A is 5% better than damage B. Okay? So that's under these conditions. What we can do is you can check for a higher raw value. So if you make an Artian weapon with 7 raw and 1 sharpness, your normal raw is going to be 225. So there's that. So that's a nice normal thing. Let's say our affinity is 50 or so from various other sources, and let's say our bonus raw is going to be 20 or so. That's like what, burst, food, a demon drug, and some other stuff. In this case, the difference between damage A and damage B, so attack boost 5 and crit boost 3 versus attack 3 and crit boost 5, is going to be 1.7%. So under these conditions, attack boost 5 and crit boost 3 is going to be 1.7% better than attack boost 3 and crit boost 5. Okay? And now we can just play with these numbers. So what if our affinity is going to be 80? Then it's going to be 0.5% better. What if our affinity is going to be 100? In this case, it's 0.1% worse. So in this case, attack boost 3 and crit boost 5 is going to be better by 0.1%. Okay? So there are going to be some cases where we're going to try and want to do crit boost 5, attack boost 3. So if our bonus raw is going to be higher, then crit boost 5 and attack boost 3 is going to be 0.56% higher, 0.56% better. Okay? So that is step 3 complete. We've actually answered our question. We've actually answered our initial question. Under what conditions will attack boost 5 and crit boost 3 do no more damage? Well, it's going to depend on your bonus raw and your affinity. So that brings us to step 4. Find the best way to show up your results. A graph, write an essay, make a YouTube video, do a speed run. So one of the cool things about Python and programming is you can always reuse code that you made prior or that other people have made and given to you. And this means that if you do something once, you can do it again and again and again quite easily. Okay? So for example, we'll never need to create another calculate damage function or another apply attack boost function because you already wrote it before, right? And so for work and stuff, I usually write a lot of code. That's nice for making plots and images, going to make it easy to see and perceive trends. Okay? So I recycled code that I used for work to make it easier to plot and see trends, in this case, between the different raw and affinity and how they affect your damage. Okay? Now, it's going to be a bit too complicated to show, like, for this introduction, but the code is going to be in the notebook, so you can use it yourself. To go through it very quickly, so over here, what we're going to do is we're going to import what are called packages. So packages are just code that other people have written and put online, and are basically just for everyone to use for free easily. A Monster Hunter equivalent is just like, making sure that you restock your items instead of trying to make everything from scratch, okay? So NumPy is a package that does a lot of math, so I don't need to figure out how to code math. I can just use their more complicated math functions. It also does something cool called arrays. If you don't know math, if you haven't done like higher level math, an array is basically just a grid of numbers, okay? A row of numbers, a grid of numbers, and they're useful if you want to do many things at the same time. Matplotlib.pyplot is a package that's good for plotting things, for making good images and stuff. Okay, so all I'm doing here is I'm creating an array of affinities. Okay, so I'm going to run this, and I'm going to show you, if I type in affinity, instead of just having one number, I have a whole bunch of different numbers. Okay, I can have affinity of 0, 20, 40, 60, 80, or 100. Okay, same thing for additional raw. I have 0, 20, 40, 60, 80, or 100. Okay. Easy. Now, what I can do is I can change the array a bit easily, so I can put in instead of 6 numbers and put 11 numbers, so it goes up by 10 each time. We're going to put a lot of numbers just to make sure that we're very clear about what we're trying to look at. We're going to put in 1,000 numbers, so it's going to go up by 0.1 every time. Okay, so we're going to look at every possible affinity. So what we're going to do is we're going to compare all of these affinities and all of these additional raws on our damage. So we're going to run the calculation we did before, but 1,000,000 times. And that way we can be very sure about our overall trend. Okay, so all we did over here is instead of using one affinity, we're doing a whole array of 1,000,000 affinities and raws. Okay, so there's that. Now all of this is simply a plotting. So if you know Matplotlib, this should be pretty easy. If you don't, basically, what this section does is it makes a figure itself. These give it some labels. These create a color bar. These draw some lines to make it easier, and this saves the figure so I can post it online. So the main thing is we need to give it our affinity, our additional raw, and our difference. Okay, the difference being what we get from our find difference function over here. Okay. So let's do that again. Let's copy this block over here. We're going to say that our difference, our diff, is going to be find difference. So we're going to say our raw is 225. Sure. We're going to say our bonus raw is now our array of additional raw. We're going to say our affinity is our row of affinity. And yeah, we're going to say our attack boost is 5, our crit boost is 3, our attack boost is 3, our crit boost is 5 for our second one. Sweet. So we're going to say diff equals this. And now we have our whole array of diffs. We have our 1,000,000 different diffs. Yep, as percentages, as fractions. Let's delete that. And now we can run this cell. So Shift Enter. And we have our array, which is not very clear. So that is because okay, so I basically set the colors to be between 5 and -5%. I'm going to just basically multiply this by 100. So our values are written out in percent instead. So let's fix that, and now we should have our differences in percentages. Sweet. Okay, so this is our sort of final plot. Attack boost 5 or crit boost 3. Come on. Let's show the entire plot on screen right now. Oh, I can just do it this way. Okay, sweet. Let's make it a bit more smaller so we can see the whole thing at once. Okay, so attack boost 5 or crit boost 3. So the different colors represent how much better attack boost 5 or crit boost 3 is over crit boost 5 and attack boost 3. When it's red, when it's like super red over here, attack boost 5 crit boost 3 is 5% better. Okay, and when it's super dark blue, the other way is better. Along the white line, they're going to be completely equal. Okay. So this is actually interesting, and this is something that we can actually use and study and learn from. Okay, so if our affinity is, say, 60%, and our bonus raw is 40, attack boost 5 is going to be better. Okay, if our affinity is 60 and our bonus raw is 100, attack boost 5 will still be better. when is crit boost 5 better? So we need to follow this white line and get past it. So we need 100 affinity and 30 bonus raw. And once that happens, crit boost 5 is going to be better. Okay? And this is sort of our final result. The rest is interpretation. The rest is thinking about it. And so when I think about this, when I look at this plot, I'm like, okay, in reality, your average affinity is going to be around 70 or so, maybe 80. You're very likely to get 100, 70 or 80. So along this range, so 70 or 80 affinity, going up, we need our bonus raw to be, what, 70 bonus raw? If you're having like 75 affinity, for crit boost 5 to be equal. And our chances of getting 75 bonus raw is very low. I can't imagine a viable way to get that. In practice, so if you have Gormagala, that's 15. Burst, that's another like 8, 23. Food and Demon Drug, 30. So I guess if you had like Dahad 5, like 5 pieces of Dahad, a bunch of Counter Strike, and had super high affinity, then maybe crit boost 5 would be better. But in general, attack boost 5 is going to be better. Now, okay, at this point, I can leave this all to you because now you can play with this a bit more. Because, okay, no, we'll do something very quickly. So just to see how good and powerful some of this good stuff is, instead of comparing attack boost 5, crit boost 3 to attack boost 3, crit boost 5, let's just compare apples to apples. Let's just say attack boost 5 versus crit boost 5, ignoring the minor skills. Okay, let's do that. Now in this case, let's see. In this case, as you can see, it's a whole lot more blue. Crit boost is going to be better in so many more situations than attack boost, right? But when you put in the other skill, things are completely different. So let's just compare attack boost 3 to crit boost 3. In this case, attack boost 3 and crit boost 3, the difference is going to be very heavily in the favor of crit boost 3. So crit boost 3 is way better than attack boost 3. Crit boost 5 is way better than attack boost 5. But attack boost 5 and crit boost 3 is better than the other way around. That's just how it works out. In practice, if you really think about it, what you realize is that... okay, so editing started out here. I think my explanation here wasn't so great in the video, so quick attempt again. Basically, all of these skills increase our damage, but I'm saying that, say attack boost 3 increases our damage by 5 something, okay? And crit boost 3 increases our damage by 10, okay? Crit boost 3 is doing better than attack boost. Now, let's say crit boost 5 increases our damage by, say, 30, and attack boost 5 increases our damage by 28, okay? So, crit boost is always going to be better than attack boost, and level 5 is always going to be better than level 3. But if you go attack boost 5 and crit boost 3, our damage increase is going to be, what, 38? Attack boost 3, crit boost 5, our damage increase is going to be 35, okay? So even though attack boost is always worse than crit boost, having attack boost 5 and crit boost 3 is going to be really good and better than the other way around, simply because attack boost 3 is so bad, okay? So the numbers are different in game, but that's basically what happens here, and that's basically why, in short, attack boost 5, crit boost 3 can be better, even if attack boost in general is going to be worse. Okay? Okay, back to the video. So, yeah, that's basically that. That's basically what I've been trying to show. Step 5, if there is one, is to just practice, learn, and get better, and just be curious about these things. So one thing I might ask is, for example, want to try implementing the skill Critical Eye. What Critical Eye does is it increases affinity by 4 per level. So if you're very curious, I might start you off on that. We might create a function that says def apply Critical Eye, which is going to take in your affinity and is going to take in Critical Eye level, and then you're going to want to return Critical Eye. You're going to try and return affinity. Okay, and you got to try and figure out what Critical Eye does. Okay, one thing you're going to want to be careful of, so this is sort of bonus, is remember that affinity is not going to go above 100. So you got to figure out how to make sure that that doesn't happen. Hint, use np.minimum. So that'll compare. that'll make sure that Affinity isn't going to go past 100. And use np.ones underscore like to compare with minimum. You want to use a function called np.ones underscore like. I think that's what I would do to compare to your Affinity to make sure you don't go above 100. If you don't bother with the np.minimum, you'll have some weird stuff that happen at high affinities because you're going to accidentally create affinities that are above 100, but otherwise it should be accurate. Okay, so if you can do this, this will be really cool, and you can see how much better crit boost, say crit boost 5 and critical i3 is over attack boost 5 and crit boost 3. So there's an option over there. So yeah, I think that's basically this video. So summary conclusions. Just always make sure you start off with an interesting, testable research question before you go in too deep. Make sure it's something that you can actually answer with the tools you have. 2, make sure you split your big question into nice and smaller questions that you can code or otherwise find a good answer to. And 3, tools like Google Colab can get you started coding right away. You don't need to install anything. Just click on the link in the description, run this, make your own code, and have fun with it and learn. And it's great and fun. So that being said, thank you to all of you for watching, as well as to my Patreon supporters, specifically Hunter Finney, who is in my highest tier supporters. Next video will be back to our normal programming. We're going to be talking all about Element. I've started some of the math on that, and it's pretty interesting and cool. Element is surprisingly strong at low values, but more on that next time. Until then, see you all. Bye.